Jump over to my screen. I think I already have, so it's a metric template. So I already have my metric template open. So I've opened up a new metric template. I've done a save as my slider block. So I'm ready to go. I've even got my PDF open. So if I just jump over uh, to our class real quick. Last one, slider block. The only thing I think you have uploaded is just the ISOs at this point. So by the end of this, oh no, I did have the ortho drawing of this. So that's helpful if you've already done your ortho drawing. It's going to probably end up looking like this. So let's try to recreate this. Then we'll get into some dimensioning where we will look at overall sizes. We might use some degrees to dimension this. But I've got this PDF open somewhere here, this one that I'm going to work from. So let's do a quick analysis of the overall size. So I know my front top, 250 millimeters for the width of the front view and the width of the top view, and 120 millimeters in height, and then 175 millimeters in depth. These are nice clean numbers to work with. 250, 120, 175. So let's go over and do some construction line work. I have to turn on my dimension layer at some point too. $250 by what I say? I always forget. 250 by 120. Okay. 250 by 120 is the front view. So this way or this way, what, 120? 120. Yeah, let's do another one of those that are orthographically aligned for the top view. It's also going to be 250 wide. So I'm going to polar track up so high, I guess. And then I got to turn off my ortho mode for a minute. 250 by 175 on the depth. So it's definitely wider than it is kind of tall for sure. You can double check those. I'll probably get in the habit of now checking my orthographic alignment on these sooner than later, probably. F8 ortho. I just do. That's good. I like that. Those look like they line up good, so I shouldn't have any issues with overall width of part. I'm just going to check this. This is always when I check my layout, my sheet layout, and I know I've got some garbage on here that I gotta get rid of. Let me get out of the command, get rid of some alignment stuff that I had. I did think I evaluated this one and I realized it's not going to fit on an A4 size sheet, right? I'm going to click in here and go to half size. We've been using half size pretty much or all week. So when I went to half size here, I was like, oh, it's actually going to be way smaller than that. Probably it's going to be closer to a quarter size is the next one down. I have pretty big adjustment there too, like a half to a quarter. Like I could definitely build some in between. It'll fit on this as a quarter size, and that'll probably be legible too. That'll probably be a good size. I might just lock that in at a quarter size. I think I chose to use my ASME or my A3 size sheet for this particular part because I think half size actually looked good. I think probably all my other ones, I felt like they looked better on the smaller size sheets up until this one of this week. Of course, I've posted imagery of both just so you can see the difference from sheet to sheet because both are adequate actually. So here we go. This is 1:1. Let me unlock it to a 1/2 scale. Excellent. And if I did use this, I'm definitely crowding. Like if I'm going to use this at a half scale, I'm going to probably pull my top view down a little bit. So this is me just evaluating what I've got to work with. Maybe I can make a true decision after I just size my viewport for max potential. That's the voltage of my, no, I don't know. This potential voltage, I think so. So yeah, I definitely could bring this together. I'm crowding space from borderland to top, and I did definitely end up putting dimensions there, sometimes below and above. So just based off this alignment at a half scale, I'm just going to run out to my model space real quick. Kind of do a quick move. That object. I'm going to stay in ortho mode. I'm just going to pull this. It's just randomly down the line here. Maybe give myself that much more room. I can pull my projectors back to where they actually project. Not that that matters too much, but now I can take another look at this on this. I like this. I think I'm going to like this better. It gives me a little more, I know it's hard to see unless I turn that off, but it gives me a little more space there like that. Maybe I've argued I moved it too much. We'll go with it. I can't remember. I haven't dimensioned this one yet, so I don't know how much room I really need. I will maybe figure that out. A4, it still fits there pretty good. Yep. I think I locked that down. Let me lock down this one too. I did. Oh, wait. Maybe I'm at the, oh, wait. I'm on the wrong sheet. Sorry. Bear with me. I just remembered I didn't lock that one down. I'm locking it down. Now I'm going back to model to draw. Let's finish my projection plane here with a 45. I'll make sure that I'm toggled on here. 45. I like it. Let's snap this in at a 45 to the top. Excellent. Let's project. Reference, click, and then across here. Yeah, if it's helpful for you, like sometimes it's helpful for me. I can actually like click here and then click again, and then I'll get a projector line that has a midpoint, which can be handy when I go to do some, if I need midpoints. I have those here and here on all these others. It's just that if I pull clear across, like I've done in a few views, and then I found that I would have liked to have a midpoint there. So if you do that, you just would click and make that two sections of projectors. You can do that too all the way across when you're doing projections, but sometimes I just pull the full line. I broke it up this time, but I think I'm ready to go. I could do a quick double check. Like this is a good thing before you spend all this time drawing. This is 175. That means your projection line uh, is true because it stayed true to size. All I did was do a quick depth check of the right side view, and it's correct. So I feel happy. And then I could do a quick height view of this because this has all just been built from projection. So if this ends up being accurate, you're likely pretty accurate with how you've done that. I just say that because if some people have distorted that, and that's a good thing to check maybe before you do a bunch of work and figure out that this was off right off the get-go. So a quick check helps. And now we just need to start doing some details. So I'll just analyze the drawing just a little bit. So I like this because I feel like just the 3D image of it in 2D space maybe makes your eye do weird things a little bit. So let me just explain what is going on here. That we just have mostly a rectangular block with a big old 30-degree miter right here. So this dimension is kind of placed like it's on the bottom view or the bottom plane. And so what I want to know is that from this front surface, it's going to be my front surface, I believe. This is kind of the imagery of this is going to be, I'm going to interpret it just as it is. This is going to be front view surface, top view surface, and this little end out here is going to be my eyeballs where my right side view is coming from. So they're looking through that way. That's how I'm going to draw. This is going to be the longest, the widest dimension in the front view. But that particular degree is kind of from the front view surface, mitered back 30 degrees. So it's not on the front view surface anymore, and it's heading towards the right side view surface. That's 30 degrees. It doesn't say down here that it's like a symmetrical part. This is where your eyes can maybe fool you. There is a 30-degree over here, but that's on a different plane. That's kind of dimension, so it should look like it's kind of on the back surface plane. So that's a 30-degree miter down from top view and down. That's this slope of this surface down to the front view, right side view, sorry. So these 30s are not the same. And it doesn't explicitly say that there's a 30 coming from this point down. And if you can just view this, it actually isn't. If it was, you should see this taper a little bit more, like if it had a 30-degree coming down there, and it doesn't. So what confuses most students with this is that actually the back surface from this is all on the same plane out to this point. So this point and this point back here, they are on the same back plane. There is no change of plane, which is why if you've looked ahead and look at my cheater notes here, that back surface is all in alignment here. And that's what I'm trying to recreate there. So this is what mostly confuses people, is that you can easily look at this and think, is it both mitered in from 30 coming to my front view? The answer is no. And then people get hung out about this little thing, and I just say, don't worry about that. If there's something, if there's some weird geometry that hangs you up, just maybe it'll fall into place using the information you have. So don't over, like I always say, if you just are focused and laser focusing on something that you can't figure out, forget it. Forget about it. And work with what you've got and see if things just fall into place. So with that in mind, I'm going to look at what my front view is going to look like. It's mostly going to be a solid line down, and it's going to jog in and do this little jog in my front view. Then it's going to come down, and it's just going to break away from my front view, but really in the front view, these are all going to look like just one solid line because I won't be able to tell this is foreshortened in my front view. So I'm just going to come across and come across. It's all going to look like one line, like the base of my front view is going to all be drawn. Then I'm going to go up, but I'm given no height here. So really what's going to define this is going to be using these 30 degrees. So I feel like I'm going to hit a dead end drawing my front view. I'm not going to know how tall this is right here. And then I'm probably going to have to figure that out for maybe the right side view or something. Probably the right side view is going to project it back across. So I'm not going to worry about how high that is. I'll just end this here. I'll come back to this. I can see that from here, I go 75 millimeters over. That dimension's here. Don't confuse it with the 90. But I'm going to go over 75. And so I'm gonna have like what looks like a little rectangle with a little a slot cut in it. And then a hole, of course, which I'll probably put in while I'm in there in my front view. That's where it's going to be visible. And then that might be all I get because I'm not going to go 30 degrees down from here to here because I've got this weird jog going on. I've got the difference of 90 to 75. And really the 30 degrees, what's that? Oh yeah, it's like it's a little bit confusing there. So maybe I'll leave that a little vague when I go to trace this. So I'm going to go over to my front view, get to my visible layer, and at least put in what I've worked out mentally in my head. And I've got that view over on my other screen because I need to know the dimensions of that little notch. So as I work this over with my visible, I'll probably put those in. So from here, it says it goes up 35. Be careful with your dimensioning. It's pretty bundled and tight in that. So this is 35 up to the notch. And then it goes in, what I have is 20. And then it comes up. I have it 30 across the gap. And then back to the left side. And that should be the notch that then goes all the way up to the top surface corner there. And then in my front view, it only goes over 75 is what I've determined. 75, and then it comes down to my bottom again like this. So that's kind of that is my eyeball surface of my front view. And then I think we determined that even though this is sloped from there, miters back, the bottom is all stays on the bottom. So this is going to be one visible line, even though so I won't see the foreshortened. And then from there, it's not 30 degrees down. So I'm going to stop there. And I don't know how far up this is. So really, I can put in the hole though now, and then I might just start projecting up and work on my top view because I feel like I'm hitting some dead ends. I'm not clear. And I just can't figure that out. So let's just move on. But let's move on after I've put in the hole maybe. So I might, the hole is like 50 over from the left side and up 25, it says. So I'm just going to cursor over 50 from the wrong point there. Try again. And then I'm going to go up 25. So that's going to be the center of hole, which is a 20 millimeter diameter hole. So that'd be a 10 radius. Okay, that's good visible line work. Let's project up what I've got. Here's 75. I'll just project it up and across. That's really only the 75 is only it really applies to, and it's not a real symmetrical part. I really can't do a lot of mirroring on this either, just by the nature of the shape of it. It's really not symmetrical from front to back, and it's not symmetrical from left to right. These are good things to evaluate when you look at parts, though, because if you can identify that early on, then you know that you might be into drawing a part by halves, right? I might only draw half this part and then mirror stuff across, kind of like we did on the last one. That base plate was very symmetrical. So look for symmetry. It's always a good thing. It can speed you up in your drawing. If there's symmetry involved, think of mirror commands. This one is just not symmetrical in any direction. It's just a total oddball piece. So it's going to kind of have to be pieced together. But it's only 75 from here over. Then it has this other weird notch slot that I didn't even try to put any of that in, honestly. Like it was a feature, this whole notch on the top. I didn't even try to evaluate from the front view. It's all hidden. It's all hidden line work in the front view. So I didn't even contemplate it very long, and I didn't even talk about it. But really, I looked at it and thought that's all hidden line. I'm gonna define this stuff probably in the top view, but it's still gonna be vague in the top view probably. So this is where these terminates going to be tricky to figure out because there's no dimensions given. They're going to hit the 30-degree plane. So this is tricky, but it works itself out. I think it looks trickier than it is, but so I've projected that up. I've got some more projection stuff. I can project up the whole. Why my ribbon menu seems to be not accepting my clicks. Frustrating. So I just went to line L command. Thank you. Here we go. So this is the whole data. It's a through hole. It says through, right? Yep, it's through all the way through the block. And then what other data can I take up? Not much. Like I've already got the overall, and I've just I could take up the notch depth here. So this is I definitely could take this depth up. And then I can see that. So now I'm just going to look at the top view profile, see what it looks like. If I on the right side, the left side surface where it appears as a line, even though it has this notch out of it, all of this is going to line up on the same line, even though it has that elevation drop. I'm not going to be able to tell that. So left side surface just appears as the full line all the way across. Then I'm going to come into that 75. Then I'm going to do something I don't know what. So I'm just going to abandon that for a minute and come over to this corner and say it comes over 90. Then it's going to come over, what's this distance? Is it clearly given? No, but it's 75 off center. That's going to lock in these lines. So I feel like I'm going to put a center line in, and then I might offset half a 75. That's how I feel like I'm going to build this surface that appears as this edge here. I think I'm going to use off of center line because I'm not clearly, I mean, it's 50 over here. And I guess, yeah, I could do the math and say, is 50 plus 75, does it leave 50? Yes, it does. So I mean, you could do either. Yeah. So a center line maybe is not totally required in doing offsets. I feel like you're right. It's 50, 50, 75. Let's just use that. Make my life a little easier. So I'm going to put in that visible work. I determined that all of that's going on would still just be solid across here. It's going to be 90 over, which I don't think I have any projectors from 90 because nothing was on the front side surface. It's 90. So this is a unique point to the back side surface that it's 90 out. Then we did our math and we figured it was 50 back into the left side view. And that's at least the topmost surface. And then I have the same thing going up over here, right? It's like 50. So I might just cursor over 50. And then this one is also, I think it lines up here 90. And then it comes in this way, but it definitely notches back to here. And I don't know what it is. So I'm just going to stop here for a minute. Like I've left that a little bit long because I know that it has a weird notch in it. And I know that this one comes over 75, which should be this longest grid point out there. And that's the point from there that it goes to 30 degrees over. This is actually, it cuts over here 30 degrees. If I look at my thing again, like at 75 millimeters over from left side over, then it miters 30 degrees. So I feel like I can show that top down looking. So I'm going to come in here and I'm going to make sure I have 30 degrees as a selector. I'm on 45. So I'm going to jump up to this next one where I have 30 degrees. I think we learned that definitely use your snaps when you're working with degrees. Definitely try to pick the snap that's available. And if it's not, if you need to put a degree in that doesn't have an O snap or a polar tracking ability, then definitely like tab over and enter it. Don't let it round for you. And don't just let it look like it's close enough. Like go over to that dialog box, type in the actual degree, and then get out of that dialog box, just so we don't have any weird rounding errors, is what I think definitely is a good advice. But from here at 75, it's going to go over 30. So I'm going to look at what that looks like. It's 30 degrees. I've got my snap tracking on. So I'm just going to pull that across. And then I have intersection on. So at 30 and intersection, I get an object snap. Just make sure that intersection is one that I always usually like to have on for that reason, intersection. And that's what it looks like. This now I can trim in the top view. And that's going to be data that I can pull down to the front view likely, because I really should show more there. But let's keep working top view. That's going to be 30 over that. The hole's going to be hidden line work. These come out further, but I don't know how far. Like these are going to come out further because that slot doesn't end at 90. When I look at this, the slot ends up further, but what terminates that is like this slope. And maybe, and I should go to my front view and maybe put that slope in, right? Like I should be able to see that slope from the front view if I bring the 90 down. That's where that slope is. So let me go back and reanalyze what I've got here. I could bring this data down from the top view now, working both views here a little bit. I could bring down the 90, wherever it is. I'll just bring it down from here, down and across. This is how long I should see this visible line longer than 75 here because I should see the back across the top. I should see that extend out to 90, even though it's not. And then from there I should see it miter down 30. Is that right? Yeah, it seems right to me. So I could use the same concept if that's the point where this like goes down from 30. So there's my 30 and then down. And then that's where the right side view is taken. I can kind of figure out how long those are from the front view. So what I'm working is just back and forth front. I never have finished this. I should go back in and like finish from that point. It goes back to the back side surface. And then this is going to come meet up with where I left it off at 90 there. So that is sloping down from there, sloping down from there, and this is sloping in. And then these extend out to where they hit that slope. It's all foreshortened in my view. But this line length actually in my view is a true length line. I just don't know what it is, but here's how it'll determine it. I haven't put it in, so I'm going to put it in as construction work first. But that slot depth is given on my drawing. Sorry, right here. It's 25 millimeters down. So I'm going to say 25 millimeters down in the front view. And I'm just going to draw that across to where it hits that miter that I just drew in. And that's going to be how long these are. And then I can project them back up to the top view and make them a visible line. So I'm going to work that out here now. What I need to know, I've got construction line on. I'm going to come down 25. That's the depth of that. And then I'm just going to pull that across until it intersects here. Those are both in like alignment through there. So I only need one line for both of those. I mean, the depth of that slot is even. So this then I can project up. And essentially this is how I want, and then I can extend these out to that line here. So that slot kind of looks like that. And then it's a visible line where that terminates against the bevel. You'll see this as kind of a hard edge here, a hard line. It's a visible line. So let me just turn this off and just take a look at what I got. It's starting to look correct. All that data's got to come around into that other view. And then I've got a hole that's a through hole in that side too. So the hole is at 40 by 25. So I'm 25 over from the back, 40 over from the left. It's the same diameter as the other one. It's through the part. And so it's 20 millimeters in diameter. So 40 and 25. Let's jump over here and put that in. Maybe I'll put in a center mark for that, or a center. Let's see here. It's 40 over this way, right? I could go either direction to put my little thing. And I already have one at 40. Is that right? Let me be careful here. 25, maybe I'll go the other direction. I think it does get really close. Like those two holes are like, I don't think they interfere with each other, but they are close, I think. So it's 25 this way, then it's 40 this way. I could have done that as construction. Yeah, I think that is 40 as well, huh? Those do line up, and that's one of the edges of the hole. So it's like this hole. Oh, do they actually intersect? They must intersect, I think, because that's the center. And then it's a 20 millimeter diameter, so it's 10 in radius. Yeah, I think those do cross each other. I must show that here. I kind of forgotten if it does. Yeah, here's the through hole. Yeah, I think so. It almost looks different than mine though. Oh no, it's there. And then okay, that's correct. Okay, good. I like it. Let's project all that stuff around the corner here. I know we're not gonna have time to, if you gotta take off before we dimension, that's fine. I will finish a dimensioning video for sure today and post it. And so just gotta take all this data around and keep track of what it is. Maybe I'm taking the external. I feel like I pulled that slightly out of alignment. Comes across this way. That's going to be the little square, I think. Yeah, that's going to be the little square. It's going to come back over to the front view side. I think I'm going to need to know these as well. Oh, sorry, I should have taken that all the way. It's really close, so I got to zoom in a little bit more. If you got those double snaps showing up, get in there close so it only has one. There we go. That and that will come across. I feel like even this is going to come across. I'm going to need to know this, like where that one meets that one. I think I'm going to need to know that. I'm going to need to know where this comes across here. And then I'm going to need the holes. Maybe I'll wait on the holes for a minute, but let me just get in the main shape. Definitely going to be just a solid line on the back or on that back side of the right side view. Across the top, it'll have the notch look. And then across the right or the front view it'll look like a line specifically because that is a whole full line up. So I'll have that show up. So I feel like with this here, the right side is going to look like a solid line, or the front view surface there is going to look like a solid line. Across the bottom, it will look like a solid line. Across the entire backside, it'll look like a solid line. And then this will be my notch. It'll come across that 50, I think. It should go down 25, across by 75, up by 25, and over to the end there. So that should be the look of the top of that part. That's the whole. And then what I should have is maybe this front little grid pattern is the very front right side surface. It's right here to here to here. So I have that. And then what we have is, I need to look at it a little bit. Yeah, we should be able to pull from here down to this point here, I think. We've just got to go in a little bit and come down, right? So let's see if we can. Maybe I don't think I've projected, or if I've projected it, it should be. I probably need these. I should have projected that over and down. That should be the point where it hits that. So let me come back to mine. I think I projected that information over right here, comes over and down. This is actually where the miter starts in this view, like this, and down to here. And that's all one surface actually right here. This is all just one seriously foreshortened surface that actually is true length this. That might be that probably is all of the visible line work on this part. Yeah, I think that looks correct. Now it's just hidden line work, and I've got to, yeah, trace my hidden lines now. I think that's it. Yeah, just hidden lines. We're close. We're gonna get our hidden lines done. We're gonna be ready for dimensions. I'll probably just keep recording. I might stop this one and do a part two when I do my dimensions, but which I'll probably just jump into right away. But let's see. I got to project across the hidden work. I've already got some of it in the upper. Like these are going to be. I've already done some projection for hidden line. It's this hole is going to appear all the way through the part right here. So this will be hidden line. And the other side of the hole all the way across. And then I think I've got to do this. Project those ones across the right side view. Make sure I pick up quadrant. And we'll trace that all the way through the part, right? Whole diameter through. And then I've got to do the projection for the hole coming down through from the top. This one needs to project over and all the way through the part. It could be that there's a gap somewhere in that part. Like I would, if the whole thing won't join, I would start joining like try fire, a few segments at a time and see what will and wouldn't join. And sometimes you can chase out maybe a corner intersection that's not happening that should be happening. Yeah. I yeah, and I definitely have said I remember mentioning this yesterday. I'm not as critical on joining these as I am just like 2D parts. And the reason is because um I view these as 3D views. And so if you don't join all these, I'm okay with that. If you do join them, that's great. If you want to join all your external, you can. But the reason why I was in those 2D drawings is because I view those as like a cut file part that a machine is going to cut for me. And these are not that, they don't fit that category. These are actually 3D views that look 2D. Or and so that's like I'm never going to like send this to a machine to cut it because it's 3D. And I mean I could send it not in this format, probably to a 3D printer. I'd have to probably convert it to another program that makes this 3D so that machine can interpret it. But really, I'm looking at 3D views, and so I wouldn't be sending this to a laser to cut necessarily, right? Because I can't send this; it's foreshortened. It's like not a true size. I couldn't cut this out as like the right side, or sorry, I couldn't cut this out as the front and then cut out the top like this and cut out. I couldn't cut these all out and put them together as a box. They would not fit. They have foreshortened things going on. And so what I would actually need to cut this is a flat pattern. So that's a cool concept to think about. If I really needed to cut this part, what I need to do is flatten it. And actually that this foreshortened distance needs to be this long. So computer programs now can do that instantaneously. We can just say, hey, what is that flattened? As long as it knows, as long as it has the views associated with it, it can figure out to flatten that. Because if you cut this out and then you tried to bend it and make it fit, it wouldn't. So it's not a cuttable part, is what I'm saying. But maybe that's not a concept you can visualize good. That's okay if you can't. But we're making 3D views, or these objects are 3D. They're not 2D. And so I can't just grab them and go and actually make something from them very easily. I have the information I need to build them, but anyway, yeah, that's a good point. And then I just got to do some center line work, right? I think that's all my. Oh, I didn't do my hidden. I didn't finish my hidden lines here for the through hold down, but yeah, it does. You're right. This one right here, right? Yeah, this totally needs a. Now that you just said that, it needs that one right there. I agree. It does. And this one is the hole, right? This is the outer hole diameter right here, all the way through the part. I mean, I like to do this because I can just use my center mark tool, and those hidden lines or will help me get my center lines like easily. So when I jump over to my center layer with my center lines, because those hidden lines are the same length as my center lines, they're just nice. They make that populating those easy. I still need to build out the extension a little bit, but just make sure you pick the right lines there. And this one here needs a center line down through. Then we need a couple center marks, one here. Oh, I need a hidden line across here. This whole notch is, I'll put the center mark on real quick though, and I'll do my extensions before I forget. But this little notch should have a hidden line across there too. So I really get a pretty big grid pattern of hidden lines uh, across that top view. So I end up with a three hidden line pattern. That's probably what I show in this little cheater here. One, two, three. Yep, that's the notch and the two bores of the hole coming through. And then in here, I've got that one that you pointed out, Kelsey, and the hole. Have I drawn those in? I think I did. And then the last thing I have is the notch in the back. So I haven't, so really the right side view needs the notch here. These needs to be projected. They would be hidden lines. So there's a lot of hidden lines on this that I need to add really still. Because I haven't put the hidden lines down through here either. I really haven't finished my projection stuff down from here. And I got to remember in my mind that I haven't finished my center line extension. Best way not to forget is to do it while you're working with it. And there we can see the lineup of, and now I remember why Sky asked, is it okay for hidden or center lines to show priority? Because we get the overlap of this here. So that's probably where that question came up. This is this one. Yep. This one. So really the center to center, they're going to bore through each other. So it's actually hard to do. If you're going to drill that by hand, that's going to be hard to do. A machinist tools are far superior, or some type of a mill situation where you can hold the block and bore one hole and then bore the other. But you're going to get one where they break through the other and there's this weird crossing pattern, which could be used as a locking device from one to the other. Anyway, I mean, that isn't an uncommon thing. You'd be like, well, how can those holes intersect and hit each other? I'm like, oh, they can actually. It could be an engineered design for something. So I don't doubt that it can be good, but I need to project these across. So it might feel like an error, but it's not. I've seen a lot of drafters make mistakes when they think they're going to re-engineer something that the engineer didn't actually do right, and they end up not understanding the whole concept of what was going on. And I've seen a drafter think that I've got the better answer, and you're like, well, technically you don't understand the full concept. So just stick with making the drawing. Ask questions. It's good to get clarification, but because I mean, I have heard those conversations go the other way too, where the engineer's like, yeah, you're right. What's going on here? Yeah. And those conversations are generally good, I say, because some engineers are not easy to work with, and some drafters are not easy to work with. And that's the top notch. So really, oh, and I noticed that the back notch, I think what I was just kind of analyzing here is if yours is the same way, but the back notch lines up with the hole. So those tend to be the diameter of the hole and the back notch ended up lining up. So the hidden line does double duty here. This hidden line is the bottom of notch and top of hole. We have a total alignment there. I'm not going to put the center line across that though. I do need to put a center line for this hole that I haven't put in there yet, like that. Now I think I'm happier with this. Hidden. Of course, I've got line type scales to work with that are wrong, and I've got these to jump out to 6 millimeter, right? These I'm just gonna. I think these little holes I'm just gonna keep. I'm not going to pull their extension lines out any further than that. There is no other round features they're associated with. So a simple center mark with its normal extensions is sufficient for that. And then these just need the 6 millimeter extensions, and I'll just do one, and then I'll match the properties of that one to these others, that one, and these two over here. To have the 6 millimeter extension. So this to me tends to be done, except for dimensioning now, right? So probably stop this recording as part one, and I'll do a